Now, you can see here valinol. Okay, valinol can be synthesized using the following reaction. Okay, the reaction one using valine as a starting material. So if you look at this valine, so basically you know that it's going to be amino acid. Okay, so amino acid. Okay, hold on, yeah. Let me check the breakout room. Or Charlton went to the wrong room. Okay, so if you look at this amino acid, okay, they say that there is reaction one, okay, and then they will change it to valinol. The thing that I can notice over here is this one stays, okay, this one stays. So the only thing that is changing over here is the carboxylic acid group is changing into alcohol. Okay, that is what they want to ask also. They say write an equation, okay, using a reducing agent. Now I want to discuss a little bit on this. Okay, what I want to discuss over here is going to be the carboxylic acid, okay, can be changed, okay, into alcohol. So this is going to be a reduction. So you need to know that primary alcohol can be oxidized to become aldehyde, and aldehyde can be further oxidized to become carboxylic acid. So I'll just put alcohol here. And then this one will be oxidized, oxidized, oxidized. You can actually get back carboxylic acid to aldehyde, and you can actually get back aldehyde to alcohol, primary alcohol, okay, using reducing agents. Okay, you're using reducing agents. Or you can actually also straight away change the carboxylic acid to become alcohol using a reducing agent, but you need to use a very strong reducing agent. Okay, so here we are talking about very strong reducing agent. Very strong reducing agent in chemistry in our syllabus is going to be LiAlH4, okay, which is going to be lithium, okay, lithium tetrahydroaluminate. And this reaction, okay, is done at room temperature. Okay, please remember this. Very strong reducing agent. But you can also, okay, use other reducing agents. Okay, there are other reducing agents, which is going to be NaBH4, which is going to be known as sodium tetrahydroborate, but it must be in alkaline condition and you need to warm. Okay, when do we use that? You will notice that in your carbonyl compound chapter, aldehyde and ketone. It means that you can use NaBH4, okay, to reduce aldehyde to become alcohol. Okay, aldehyde to become alcohol. Can you use this to for carboxylic acid become aldehyde? Most probably can, but they didn't mention it in the textbook. Okay, but if you want to change carboxylic acid straight to alcohol, primary alcohol, you need to use a very strong reducing agent, which is going to be LiAlH4. This is very, very important. You cannot use NaBH4. Okay, that is what I want to highlight. Okay, which I actually put it over here. Another thing that I want to also mention is going to be, I think, since we are talking about primary alcohol, we do have secondary alcohol. Secondary alcohol, they can be oxidized to become ketone. Okay, and you can use the oxidizing agents, and ketone will become reduced to become secondary alcohol, and this is going to be done, okay, by using what you can either use NaBH4 or LiAlH4 in dry ether. Okay, both also can. Okay, so this one we just take note. Okay, now the oxidizing agent, okay, this is also very important. In chemistry we use, okay, most common oxidizing agent is acidified potassium manganate and acidified potassium dichromate. They are very, very popular. Okay, and you need to know the color changes as well. Purple will become colorless for KMnO4, and orange will become green for K2Cr2O7. But on top of that, we do have, okay, oxidizing agents, okay, which are considered to be a mild oxidizing agent, mild. Okay, so we don't use it for all the time. Okay, we use it for, let's say, for certain reactions. So we can use Tollens region. we can use Fehling solution. So what is Tollens region? Tollens region is going to be silver nitrate solution with excess ammonia. What is Fehling solution? Is alkaline copper 2 plus solution. So what they function as, okay, basically we learn this in carbonyl compound as well, where carbonyl compound, okay, especially the aldehyde, because aldehyde can be further oxidized to become carboxylic acid. So we can use it to test or to differentiate aldehyde with ketone. Okay, so if I want to actually test for aldehyde, I will use Tollens region, I will use Fehling solution. So what is going to be the observation? You should know Tollens region, okay, you are going to use silver. So it's also known as silver mirror test. You are going to get some kind of a mirror formation. Okay, so Ag plus will become Ag. You can read on this. Fehling solution, copper 2 plus will become copper plus, which is going to be formation of copper 1 oxide. Copper 1 oxide is going to actually give you brick red precipitate. Okay, brick red precipitate, and this one also you will need to know, you need to warm the mixture. Okay, you need to heat. Okay, so this is going to be the reactions that you need to know about oxidizing agent, mild oxidizing agent. Now let me talk about, since we talk about oxidizing agent and reducing agent, let's actually cover everything. Okay, all this that I mentioned just now is only in AS. Now we also learn in A2. What are the things that we learn in A2 related to oxidation? Okay, I didn't put the reduction over here because I think yesterday's lesson we have done the reduction. Okay, for example, nitrobenzene, you can reduce to become phenylamine. Okay, how to actually do that? You use concentrated hydrochloric acid and Sn. Okay, stanum. Yeah, Sn. Okay, and concentrated ACl. I can show you over here. This one. Okay, tin. Okay, tin and Sn. Okay, you can actually use to reduce. Okay, nitrobenzene. Okay, any NO2 group, you can actually change them into NH2. Okay, so this one is going to be reduction, but I want to cover the oxidation for A2. Now for the oxidation part, okay, we also learned that in A2 you can oxidize. Generally carboxylic acid cannot be oxidized, but you can oxidize two types of carboxylic acid. One is methanoic acid, another one is ethane dioic acid. Now, in order to oxidize methanoic acid, you can even use, it's very easy to oxidize. You can even use mild oxidizing agents such as Fehling or Tollens, or you can use the strong oxidizing agent. So methanoic acid can be oxidized with any oxidizing agents. But for ethane dioic acid, okay, you need very strong oxidizing agent. You cannot use Fehling, you cannot use Tollens. You must use KMnO4 or K2Cr2O7, acidified generally, yeah, the condition. Okay, this is going to be what we learn in A2. On top of that, okay, we also learn, okay, if you have oxidation of side chain, let's say if I have methyl benzene, I want to actually oxidize that. Let it be methyl benzene, ethyl benzene, whatever benzene that has attached with alkyl group. You can oxidize them, okay, you can oxidize them, but you need to remember the condition. You oxidize them either with KMnO4 or K2Cr2O7, but generally we use acidified. But now, okay, this is based on your textbook. You use alkaline solution of KMnO4, then reflux, okay, after that you acidify with H2SO4 concentrated. So there's going to be a different condition over there. Okay, slightly different. What is different? The extra thing is going to be alkaline. It must be in alkaline condition. After that, you acidify. Okay, so this is going to be slightly different. Okay, slightly different than the normal oxidation. If you want to use K2Cr2O7 in the textbook, they didn't mention very clearly, but I assume because they are both strong oxidizing agent, I assume same condition. Alkaline, K2Cr2O7, then after that you reflux, then you add concentrated sulfuric acid. you are going to get benzoic acid. Okay, these are the things that we need to take note about oxidation. Okay, I have covered everything. Now, writing the equation, okay, you can use any ways to write the equation. I think the best way is to write in this form, okay, or if you want to write using structural formula, up to you. They do accept that, but you need to know, okay, from where you get this 4. Okay, the 4 comes, okay, because this one will be broken, and then the one of the hydrogen will come over here to form the alcohol. Another 2 hydrogen needs to come to form the bond here and here. Another hydrogen has to come to form bond with the OH to form water. So how many hydrogen that you require? You require total of 1, 2, 3, and 4. Okay, that's why there's 4 over there. Okay, suitable region, there is no other regions. Okay, do remember this is going to be carboxylic acid to alcohol. So there's only one region that you can use, which is going to be a very strong one, LiAlH4. Okay, here they say suggest, they didn't say state. You can still write the short form. Okay, but if they say state, please remember, if they say state, then you need to remember lithium tetrahydroaluminate. Okay, but most of the time they say suggest. Okay, so generally still okay, still fine. Okay, but just take note if they say name. I think especially not the state also still okay, you can give this, but if they say name, you need to write the full name. Okay, but most of the time I don't see them asking the name. Okay, so just in case, I'll let you know. Now, name the mechanism for reaction 2. You can see this reaction here. It's going to be, the only thing that is changing over here is also from Cl suddenly changing into OH. Now, what is happening is, okay, hold on, let me check who just joined just now. Okay, everyone's okay. Jason, okay. Now, if you look over here, okay, what is happening is going to be halogenoalkane. This is halogenoalkane is changing into alcohol. This is again your AS topic. Okay, halogenoalkane. Anything involving halogenoalkane or any reaction involving alcohol, there is only one type of mechanism, which is going to be that in that particular chapter only we learn about Sn1 and Sn2. I think this is the best way to remember. Only in halogenoalkane and alcohol we learn about Sn1 and Sn2. So Sn stands for nucleophilic substitution. So if they ask you name the mechanism, very easy, just nucleophilic substitution, because I remember it is Sn1 and Sn2. Okay, which is going to be halogenoalkane changing into alcohol. Okay, so this is going to be the reaction, and then how, okay, they are going to use the NaOH. Okay, sodium hydroxide. Okay, sodium hydroxide, and there are 2 different reactions. Okay, which is involving sodium hydroxide. Okay, can you tell me what is going to be the condition? Okay, halogenoalkane. Okay, let me check. You guys, if you have your textbook, please check halogenoalkane. What is going to be the condition? There are 3 reactions. One is going to be cyanide in ethanol. Okay, which another one is ammonia in ethanol. One more is going to be the reaction of sodium hydroxide, okay, reflux. And one more is going to be hold on, elimination reaction, which is sodium hydroxide with ethanol. Now, elimination reaction, okay, is going to be with ethanol. So this one is going to be without ethanol. Okay, so this one without ethanol. Okay, please actually remember all this. Okay, so this one, okay, if you quickly refer to your textbook, there are total 4 reactions, okay, under that chapter. One is going to be the reaction with cyanide ion, reaction with a hydroxide ion. Okay, there's 2. Okay, one is going to be the normal with sodium hydroxide. Another one is going to be with sodium hydroxide, but ethanolic. Okay, ethanolic. And then the last one is going to be the reaction with ammonium. Okay, ammonium, and also must be ethanolic. Okay, please go through this. Okay, go through this. But anyway, we are not talking about elimination reaction over here. Okay, because no ethanol. Okay, so if they ask you what is the condition, I think it must be heated. Okay, or it may be under reflux. Okay, but okay, what I want to also teach you over here is going to be related to halogenoalkane changing into alcohol. Okay, we have two types of mechanism. Okay, which is going to be Sn1 and Sn2. So I want to also use this opportunity to teach you about the Sn1 and Sn2. Okay, so if you look over here, this is going to be halogenoalkane. Okay, that is attached to one R group. So this is called primary. The carbon is attached to one R group. Yeah. So this is called primary halogenoalkane. Okay, primary halogenoalkane. And for primary halogenoalkane, we also have tertiary halogenoalkane. We also have secondary halogenoalkane. Why we talk about this primary, secondary, and tertiary? Okay, because I want to identify which mechanism Sn1 or Sn2 will be selected. Now, for primary, okay, I think one of the best way to remember tertiary. Okay, do remember about carbocation, Markovnikov rule last time, okay, in AS. Okay, Markovnikov rule say that the carbocation that has the most R group attached to it is more stable. Okay, what we call as positive inductive effect. But we just focus over here. If you have, okay, carbocation, okay, uh, carbocation will be more stable if you have tertiary carbocation. This is Markovnikov rule. Now, in order to get tertiary carbocation, you can only get it from tertiary halogenoalkane. So it means that whenever we are dealing with any tertiary halogenoalkane, we are dealing with the formation of carbocation. Simple as that. If you are talking about primary halogenoalkane, you are going to form primary carbocation, which is not stable. So we do not use that method. Okay, we do not use that method. So what is going to be the mechanism? This one, I leave it to you to remember. I remember like this, tertiary, then I remember 3 to 1. Okay, it's going to be opposite. Or if I have primary, I don't use Sn1. I will use Sn2. But how do I remember Sn1 and Sn2? Basically by this relationship. If I have tertiary halogenoalkane, I want carbocation. What kind of carbocation that I want? I want tertiary carbocation. Okay, so if it is tertiary carbocation, because number 3, I want to form using Sn1. So that tells me Sn1 is formation of carbocation. So I actually get my information using that. So Sn2, what is Sn2 then? Sn2 must be something that do not involve carbocation formation. So it must be formation of intermediate or formation of transition. So this one you need to take note of that. Don't know whether I wrote something around here. No, I didn't actually write anything here. So basically, please go through, okay, please go through about this Sn1 and Sn2. If you want to know details about this later, I'll share the link of the video in the WhatsApp group. Yeah, I have done one video 2 years past. Okay, maybe the audio is not so good as well. Okay, but I have covered about Sn1 and Sn2. Okay, so you can actually go through that. Okay, how do we use Sn1 and how do we use Sn2? How do we write using curly arrow diagram? Very, very important. Here you see, you are lucky if they just use this 1 or 2 marks. Okay, but this question can be extended if they ask you draw the mechanism of the reaction. Then easy 3 marks already. Okay, if they want to include that. Or if they say suggest what kind of mechanism Sn1 or Sn2. So that's going to be another 1 more mark. Total 4 marks over there extra. Okay, so they didn't ask over here because I think they are focused on polypeptide. Okay, so next question is going to be drawing a structure of tripeptide. So in drawing this structure of tripeptide, very important, how do you arrange? Okay, this is very important. I arrange, okay, glycine. I refer to the glycine over here, okay, that is given. So I just arrange it this way because I know the NH2 must be one side, COOH must be the other side. And then they say valine, okay. If I look at valine over here, NH2 is somewhere here, okay. So of course, I want some reaction to happen. So I need to rearrange it properly. So the structure of valine, I try to rearrange. Okay, the carboxylic acid, I'll erase this part. The carboxylic acid part, I try to put it at one side. The NH2, I try to put it one side so that I can actually do the condensation reaction. Okay, so here I end up putting NH2 here. Okay, I put NH2 here, and then COOH, I put it this side. Okay, it means this is going to be my central carbon. Okay, so I intentionally bring the NH2 on my left. Okay, why? Because I want to react with the carboxylic acid. Okay, and then I just move, okay, this carboxylic acid group to the right. I just move it to here. So what is left is going to be the hydrogen here. Okay, and sorry, what is left is the hydrogen here, and also, okay, this entire group. Okay, so I just put hydrogen here and that entire group over here. So I did the same thing. I just take this entire thing, I put it over there. So what happened is now I can show, okay, which one I want to remove. Okay, it's easier in that way. Okay, so I know that this one is going to be removed, and I'm going to remove this. Now, do remember this is not polymer, okay, where you still need to extend this or here. No, they already mentioned is tripeptide. It means this peptide, okay, only have 3 amino acids, okay. So you do not need to actually put like something like, I hope you understand what I mean. Something like normally for polymer, you do like this. No need to do that. Okay, no need to do that. So what we will do, okay, just put it there. And then, okay, I intentionally also, okay, I put the carbon double bond. Then this bond bonded to nitrogen and hydrogen. Intentionally, I'll bring it to here so that it's easier to show, okay, it's a peptide bond, okay, or peptide linkage. So I'm not sure which one, because you see here, show the peptide bond. Okay, do I show peptide bond carbon and nitrogen? Maybe not accurate. So I'm not sure also. So what I did was I put the entire linkage. I show the entire linkage. Okay, I show the entire linkage. But just in case, if let's say the marking key is going to be peptide bond is this one, I just put another arrow to show it's a peptide bond. Okay, so I'm trying to secure all the parts to get the answer. Okay, but what they want is basically as long you can show the CONH bond, that is already peptide bond. Okay, so to be safe, yeah, please actually play safe. Yeah, because we are spending time to draw this and this just for 2 marks. Okay, of course we don't want to waste that 1 mark. Okay, if let's say we spend a lot of time and then we are getting more marks, like for example mechanism and so on, it's okay. Okay, but this one we are spending a lot of time and to gain only 2 marks, so let's do it properly. So that is actually what I put over there. Now, so for this, okay, the valine, okay, exists as two stereoisomer. So let's actually look at valine. Now, when they say two stereoisomer, okay, the moment I hear stereoisomer, yeah, I can remember only optical isomerism. Why? Automatically, I have a chiral center here. A chiral center must be something that has 4 different groups. I can see 4 different groups there. So straight away, I know this is going to be optical isomerism. So I just type of isomerism, I just straight away put optical isomerism even before I start drawing. And then they ask you to draw, okay? And then the first thing that I need to draw is the carbon, the chiral center. I put the carbon, and then this carbon has hydrogen, NH2, COOH, and this group. But this group, you don't even need to actually write it down because they already say that you can represent using R. So quite simple. What I do is first, again, yeah, this is very important. Even some students, they forget about this. When you draw, okay, draw two same plane. It means the line, two lines. Okay, there will be two lines. You can put any. Okay, like for example, NH2 at the top, H at the bottom, doesn't matter. Okay, so I selected hydrogen at the top, NH2 over here. But do remember, the bond is going to be with nitrogen. So I put NH2 here. Okay, with the nitrogen. Or you want to write down in this way, also can. Maybe NH2. But make sure the bond is towards the nitrogen. Okay, and then I want to actually just put like this. If you want to darken this, also can. Okay, to show 3D diagram. Okay, R, it is actually coming towards you outside of the monitor, or coming outside of the paper or something. And then to also show that one group is going behind the paper or behind the screen, you can either use dotted line. Okay, if you have time, I would suggest, instead of doing the dotted line, hold on, yeah. Instead of doing the dotted line, there is another way, which is going to be, you draw like this. Yeah. If you have time, yeah. So I'm not going to force you. Something like this. Okay, if you can draw that. Or normally they actually make it a little bit like this. Okay, if you can draw like that, it's good. Now, the mirror image. Okay, the mirror image. How do I draw the mirror image? Very simple. Okay, you just imagine there is a mirror here. Okay, and then simply assume there's a mirror there. Replicate the entire thing. Carbon, I put carbon here. Hydrogen, just replicate. Straight. Replicate. Okay, hydrogen, NH2. And then replicate, even like this. Okay, it's pointing towards the mirror. So this one also pointing towards the mirror. And put the R group. And COOH. Why I put COOH like this? Because I want to show that this carbon is attached to carbon. Okay, so if you have time, this is again, I'm not going to force you. Okay, but you will see that in a lot of your marking key, they are actually drawing like this. So if you have time, please do that. If you don't have time, dotted line will do. Okay, if you are rushing, yeah, dotted line, it's fine. Okay, it's better to answer everything rather than doing everything nicely, then you couldn't answer. Yeah, so this is the part that I wanted to discuss. Okay, then again, yeah, another one. Okay, valine is going to be amino acid. Draw the zwitterion of valine. So the one that they want to see, okay, is going to be the negative charge here, COOH. The H plus comes here, and then the positive charge, okay, towards the nitrogen. Okay, towards the nitrogen. So basically, don't write NH3 and then put positive over there. It doesn't make sense, because it's supposed to be carbon bonded. Okay, carbon bonded to nitrogen, hydrogen, hydrogen, hydrogen. This is going to be positive now. Okay, not the hydrogen. So that is what why it must be towards the nitrogen. The moment you draw the correct zwitterion, okay, so that's going to actually give you 1 mark. So they will not give you more than that. Okay, it's going to be 1 mark. And then this is going to be K step. Okay, stability constant. Yeah. So in this case, okay, this is under transition element. Okay, valinate, okay, is an anion of valine. Okay, still the same question. Okay, if you look over here. Okay, it means now if I recall about this question, they started, okay, this question with amino acid, and then they ask about, okay, some AS stuff. Then they go into polypeptide, okay, organic nitrogen compound, okay, polypeptide and so on. Then they also come back again, okay, to your AS. Then also coming back to A2, asking about zwitterion. And then now, okay, going back to your A2, but different topic. Okay, you can see how they are relating everything. So in this topic, you see they if it is combined, They only ask 3 marks question over here. Okay. But if it is not combined, possibilities of them asking more will be there. Roughly, we are talking about 11 marks. Okay, roughly about 11 marks, not more than that, unless they really want to test you on this. Then they will give you 11 mark, more than 11. But I don't think so. I think for this chapter, 11 marks is all right. Okay. Now, when you have this equation, one of the things that you need to take note is going to be when I write, okay, I will not include water. Okay, this is the expression, okay, normal expression, okay, and just put it here and then 2, so to the power of 2, okay, I just put it everything here. So this 2 plus, I think to be safe, I'll just put it here inside, okay, so that we don't get confused. Okay, so what is important is not to include water. Okay, so water is going to be if it is liquid, okay, we just take it as a constant. Okay, we don't actually include it in case that. Okay, now at room temperature, okay, the numerical value is 2.35. How to do this? Okay, always refer to here, 10 to the power of 5. Now, 10 to the power of 5, okay, we are referring to 1, okay. If you have K step, okay, if it is going to be this one, product divided by reactant, if it is 1, it means they are at the middle, okay. If it is more than 1, okay, if let's say more than 1, so it means that this side, the top part is going to be more, okay. It means that the right hand side will be more, okay. The position of the equilibrium is towards to the right. If it is less than 1, okay, if less than 1, that is going to be, you are going to have more of this, less of this. Okay, so your position of the equilibrium is more towards your left hand side. This one is more towards right hand side. So here they are asking us to explain what this value indicate about the equilibrium. So you just tell, okay, it's more than 1. Okay, since K step is more than 1, K step more than 1, so therefore, okay, the position of the equilibrium is going to be shift. It lies, okay, it lies to the right. Okay, so it lies to the right, and then to answer stability of complex Z is going to be, this is complex Z, and then stability. So since it's actually towards to the right, it means this is more stable. So whenever they are forming something, so they like to form something that is a stable. So of course that is more stable. So you can say Z is more stable. Okay, if you want to compare to NiH2O6 2 plus. If you don't have time, no need to even compare. Okay, you just say more stable is enough. Okay, because it's only 1 mark. Now, in order to get this 1 mark, you need to make sure you mention both to the right and more stable. If you miss one of it, you will not get the mark. If you say to the right, didn't mention about stability, you won't get the mark. If you mention about stability, you didn't mention about to the right, then you will not get the mark also. So please take note. Okay, because sometimes when they give you 1 mark, it can be very killer. Yeah, they kill you. Okay, if you don't actually hit the points. Okay, if you don't hit the point, okay, you are not going to hitting 1 point, no problem, but hitting the 2 points, okay, maybe will be difficult for some students. Okay, so that is very important. And then here the last one, they mentioned about total 11 marks for this, the entire question. They say that Z is going to be an octahedral complex, so with the formula, so you can see it's an octahedral. So octahedral coordination number is 6. Okay, you should know this. So I have H2O, okay, H2O, okay, they only form, okay, H2O2. It means 2 molecules of H2O. Okay, even though water has 2 lone pair, okay, of electron, they are monodentate. Okay, they are monodentate. They only form 1 dative bond. Okay, so if I have like nickel, okay, octahedral will be something like this. So if you have 2 water, most probably this one is going to be related to water. This one will be related to water. The remaining 4 must be with valine. Okay, but there's only two molecule of valine, so maybe valine, one here, one over there, valine, one here, one over there. So each one valine is going to form two dative bond. Okay, if you have two dative bond, so this is known as bidentate. This is how you determine whether which is going to be the type of ligand. Okay, now the rest of it, I think this one I just did a little bit over there. Okay, maybe you can actually go through yourself. Okay, what is going to be how do we define the term of standard electrode potential? Okay, you define, okay, based on voltage of an half cell, okay, in a comparison to hydrogen half cell. Okay, but in order to get the full mark, the 2 mark, you need to mention about under standard condition. Under standard condition is good enough, but if you want to explain more what are the standard condition, the standard condition is 1 mole per dm cube, 1 atm atmospheric pressure, and 298 kelvin. But okay, you need to make sure that you mention about voltage of an half cell, okay, or voltage of an electrode. So voltage of a half cell in comparison to hydrogen half cell. This is going to be important. Okay, and measure under standard condition. That will lead to 2 marks. Okay, sometimes okay, students just say voltage of a half cell measured under standard condition. How many marks will you get? Only one. Okay, you will only get 1 mark. Okay, so you need to always compare with hydrogen. That's why they are called standard hydrogen electrode potential. Okay, standard electrode potential. Okay, so they are always measured with the hydrogen half cell. Okay, in your data booklet. Now draw a fully labeled diagram of the apparatus that should be used to measure the standard cell potential. I didn't complete the diagram, but generally you will have 2 beakers. Yeah, 2 beakers, and then you see here, okay, this is going to be aqueous solution and solid. Okay, so if I have aqueous solution and solid, maybe I can just draw now aqueous solution. So aqueous solution, gold in aqueous solution, and then another one is solid, so you just draw the solid. Okay, just put over there. Okay, so this one is going to be AU, and then okay, at this side there is going to be aqueous and gas. The moment you see gas, then you need to actually contain the gas. So how do I contain the gas? So I put the solution, and then I must actually use platinum. Okay, I use platinum. I need to contain the gas, and then the gas must be coming from somewhere. Okay, let me draw. Maybe I just put like this. Okay, the gas must be coming from somewhere. So the gas that I will put, I just put NO and then put here. And then you will go to the platinum. So this platinum, okay, of course, have to, I think no, even doesn't make sense. It's okay. Okay. So basically that's going to be the platinum is connected. Okay. I think the best way we can do is, I think this is fine also. Okay, basically the platinum must be connected to what? Okay, don't forget, yeah, voltmeter. Okay, do we need, okay, battery? Okay, now this one, this is cell potential. Okay, it's a chemical cell. Okay, chemical cell, no need battery. Okay, no need battery. So you have this. Okay, make sure everything is labeled properly. Okay, include all the necessary chemicals. Everything is there. I think I didn't label this one. Okay, HNO3 aqueous, and then I think on top of that you need to also mention that, okay, this one is going to be 1 mole per dm cube. 1 mole per dm cube. I think the rest is okay. I think good enough to get the 4 marks. Okay, 4 marks. So this is important. Okay, how to get the 4 marks. Okay, why platinum? Okay, because I think you need something that can conduct electricity. Must be something that conducts electricity. You can actually check. Okay, I think other than platinum, you can use graphite. I think. Let me check for you. Yeah, you can actually see even the electrolysis, when it comes to electrolysis of hydrogen cell, we use platinum also, platinum electrode. And then the way they draw also, I think the way they draw is like something like this. Maybe I don't want to mess up the diagram. They draw like this. They put the test tube, they put the platinum, they bring this wire then to the voltmeter, and then at this end they will use the some kind of hole over here, then they actually bring in the gas. So this one is the half cell of the hydrogen. Yeah, for hydrogen they actually need to supply the hydrogen gas here, and then you will need to use platinum. Okay, and then you are going to use the acid H plus. That's going to be the hydrogen half cell. Okay, so similar to that, I think this is also H plus. This is PT platinums. Let me see whether you can use other things. I think most of the time they actually use platinum. So it's platinum. Okay, let me see the marking key also. It's platinum. Yeah. So even in the marking key, Gabriela Nicole, they even use platinum. So what is the reason why we use platinum? You cannot use some other things, okay? Because we want something that do not react, okay, with our HNO3 and do not react with the NO, okay? So, but must actually be able to conduct electricity. So that is going to be the requirement. So we use platinum. Can we use carbon and graphite? Generally, yes. Okay, but I think in this chapter, I don't see them using carbon and graphite in the textbook. Okay, so that will be something maybe I will actually reserve if I want to use that. So normally I'll use platinum, because even in the textbook, they mention about the hydrogen half cell, they use platinum. Okay, one of the concern why they don't use platinum, because it's expensive. But since they are using platinum, yeah, let's use platinum. Okay, so the others I didn't do yet. Okay, you can actually continue with that. Okay, or if you want to join the group, it's already 12:22. You can continue here, or you want to join that group also fine. Or you want you have any questions to ask, you can also